video, we are going to be modeling a trigonometric function by looking at rockets and Seth. So Seth is observing today's rocket launch at Cape Canaveral from the viewing area about 3 miles away. We're going to write a function to model the height h of the rocket as a function of the angle incline theta from Seth's position in the viewing area to the rocket. Then we're going to identify the appropriate domain and use of the function to describe the motion of the rocket. All right, so we're seeing here Seth is 3 miles away. We have some angle theta and the rocket is launching up. There's a lot of information we don't know here, but I do know that it might be kind of best to use tangent here because again we want to function of the angle, write a function to model the height of the rocket. Oh, because we're given the height of the rocket h. So we're going to use tangent for this. I knew we had something in there that we needed to use tangent, which is the height of the function. Height of the rocket. So there's the height of, that's a nice drawing on there. There's the height of the rocket there. So I'm going to use tangent of theta is equal to opposite, which is the height of the rocket, over 3. All right, we're trying to find the height. We're trying to write an equation for the height of the rocket. So I'm going to isolate h, multiply 3 to each side. So now I have 3 tangent of theta. Okay, in the context of this problem, remember tangent has the vertical asymptotes at any odd number n. So basically pi over 2 plus n pi values. All right, so we need to think of a domain that would work for that. Well, we can't go negative. We're talking about a length here, so we can't go with the negative domains. And we also know that we have to be within pi over 2. So I'm going to say that the domain of the function and we're going to keep it between 0 and pi over 2. Theta pi over 2. I mean, we could go to 3 pi over 2, but we'll keep it within that first iteration of 0 and the vertical asymptote. All right, because the rocket will never be directly overhead is again why we're doing pi over 2 as well. We're never going to have it. So if this is pi over 2 overhead, get to this guy right here. Overhead would be another pi over 2, which would be the 3 pi over 2. So we're not going to ever be overhead. We're good with just pi over 2 here. All right. So looking at that, the range, because I think they want the range, change that back to yellow. The range will then be, again, the rocket is hopefully not going down into the earth. So we know that the rocket is going to be above 0. For the height can't be 0 because of the height 0, we have no rocket. So the height of the rocket is always positive. So here is my, okay, I didn't finish that out. Here is my equation to model the angle of which Seth is looking at the rocket. We know that he is going from 0 to pi over 2 because anything above would be the rocket above his head. And again, the rocket doesn't go into the ground. The rocket's height has to be at least 1 because you don't have a rocket if it's not greater than 1. And there you go. So we have identified the appropriate domain and use of the function to describe the motion of the rocket. If you guys have any questions, this was kind of a arbitrary example. It didn't quite go into great numbers and go into great depths. It just makes you think what is appropriate for this problem. Remember, once you pass pi over 2, you're back into y of the negatives. Your range is negative. So the next time you see positives would be at pi than to 3 pi over 2. So that's why we chose pi over 2 and we didn't extend it further, because the y's are negative until you hit pi. And then they become positive again. And so we'd have that big break in our domain. So it's been, and again, like they said, when you hit pi, it's basically gone above his head, and we're not looking at above his head. So anything between 0 and pi over 2, because then it's not going to go over his head like this. I mean, I guess it could, but let's hope it's not, because it's going into the outer space. So this is 0 to pi over 2. If we're looking at the unit circle, if we're looking at this as a unit circle. All right, guys, so if you have any questions, please always feel free to ask, and I'll catch you in the next video.